All right, so let's do some more problems for section 4.5, integration by substitution. All right, so let's do the integral of 1 over x squared plus secant squared of pi x dx. All right, the nice thing about this, if you remember back from the properties, we can treat them as one at a time when it's addition and subtraction. So I'm going to do the integral of x to the negative 2 dx plus the integral of secant squared pi x dx. And I can do each one separately because it's addition or subtraction, and then just combine them at the end. So this first one, the integral of x to the negative 2 dx, is not bad at all. It is just x to a power. So we can integrate that fairly quickly. So add 1 to the exponent, I get negative 1, divide by it. So I get x to the negative 1 over negative 1, better known as negative 1 over x. Now, yes, typically we put plus c, but I'm just going to put plus c at the end of everything because I'm going to add a constant here, and I'm going to add a constant here. When you add two constants, you still get a constant. So that first half is done. Excuse me. That's why we like to split it up. That part's not that bad. All right. So now over here, I have the integral of secant squared pi x dx. That is not one of the basic functions because my angle is not just x. So in order to do this, we're going to need u substitution. And because my angle is not just u, I'm going to make my u be my angle. I'm sorry, because my angle is not just x, I'm going to make u be my angle. So u is pi x, which means that du dx is pi, or du equals pi dx. All right, so now I'm going to have to go down below to be able to do this. So I have the integral of secant squared. My pi x is now just u. Let me go down here. So I have the integral of secant squared of u. And then I want to say du, but does it match up exactly? It does not, because what I have over here on the side is dx. It doesn't match up exactly. I have to get rid of this pi here. So let me divide each side by pi, and I get 1 over pi du equals dx. So now I can go ahead and get rid of that right there, my ink tools. My dx up here is going to now, because dx down here is 1 over pi du. So I'm going to get rid of my dx and put my 1 over pi out front, du out back, because 1 over pi is a constant. All right, so bringing down from above my negative 1 over x, and then I'm going to add to that my 1 over pi, and then the integral of the secant squared of something is the tangent of it. So I get tangent u, and then this is where the plus c comes in. Now, I don't want to leave u in my answer. So I get negative 1 over x plus 1 over pi, the tangent of something, plus c. This is why everything has to be labeled. Go up and remember what u was. U over here I labeled as pi x. So that's what's going to go inside my parentheses, pi x. And this is my final answer. All right, let's do another one. All right, the integral of sine squared x times cosine x dx. Well, here my angles are just x, so that's good. There is no such thing as product rule or quotient rule for integrals, so I can't do that. I said earlier, typically we pick u to be what's raised to a power. So I'm going to make u be sine x. If u is sine x, the derivative of that is cosine x, and that matches up very nicely for us. So again, I want to get du by itself. So I'm going to say du is cosine x times dx. So my integral then becomes the integral of, so remember sine x is u, so this becomes u squared. And then cosine x dx, this whole thing here, becomes just du. So we always want to use direct substitution for that. So that becomes just du. So up top, it was always in terms of x. Now it is all in terms of u. I can go ahead and integrate. So I'm going to get the integral of u cubed over 3 plus c. And I'm sorry, I don't want the integral there. Add 1 to the exponent and divide by it gives me u cubed over 3 plus c. Put your u information back in. U cubed, if we remember from up here, is sine x. So I get sine cubed of x over 3 plus c is the final answer. All right, if you have any more questions on these, please email me, or you can look them up on the answers on Calc Chat. You should definitely be doing homework. You can look up things on Khan Academy and other places. Hopefully, by the time we get to this point, campus will be open again, and I will be able to post more videos. If not, we're going to have to go with my notes. I apologize. Good luck and stay well.